Hello and welcome back to the Knowledge Catalog's Grade 9 Physics. This is the fourth episode and it is divided into the following parts. The first part is Gather Information's Activity 61, which is entitled Catch Me. And then the second part is Gather Information Activity 62, entitled Throw Me. And then the last part is Gather Information Understanding Check, which is about a concept map. Hi, so for this version of Grade 9 Physics, we are working on the following learning competency, which is describe the horizontal and vertical motions of a projectile. It has that kind of code. Okay, ayun siya. It's not actually this one right here at the bottom. It's right here. Okay, yun nandun. Okay, so if you want to follow through with some sort of the reading material, you need to have a copy of the 7E based self-learning module in science, which I have developed, and open it in Unit 4, Book 18, pages 10 to 20. Let's begin. Okay, for the first part, Gather Information, Activity 61, Catch Me, we have the following objectives. The first objective is you should be able to explain an object's motions in terms of its horizontal and vertical components. Okay, by the end of this activity, you should be able to do that. And apart from that, you should also be able to describe the motion of a projectile that is launched horizontally. So, dapat kaya mo rin i-describe yun. So, the materials that you need for the following are, for the activity are the following: paper, pencil, and a calculator. Okay, so a bit of a background. Look at figure number 124 and, notice the ball that is dropped, the blue ball that is dropped, and then notice the red ball that was launched horizontally. Okay, so I hope you understand na itong ball na to talagang binitawan lang siya. Ito naman, nandito siya kanina tapos na-push siya pa ganon, papunta dito. Well, syempre, fly off siya from the table, tapos it landed here. Okay, so it landed here, it means hindi to yung final position niya, pwedeng hindi ito yung final position niya, pero this is where it first hit the ground. And if this is the table, okay, notice the distance. Okay, alin sa dalawang balls yung mas malapit sa table? Okay, so the vertical distance that was covered by this ball is similar to the vertical distance covered by the other ball. So they have the same vertical distances. The red ball was pushed horizontally off the table, while the blue ball is dropped at the same vertical distance. They reached the ground. This is a new detail. They reached the ground at the same time. So kahit na iba yung manner ng pagkaka-launch sa kanila, okay, kahit na pareho yung yung tawag doon, yung vertical distances nila, and also pareho yung time nila. Okay, so ano kaya ang pinagkaiba nila? Okay, so yeah, so far they have the same vertical distance and they have the same time. Okay, pareho yung time na tinake ni red at saka ni blue ball to go from this point to that point. Pareho lang yung time and yung distance, but the way they were launched, it's different. So yeah, ano kaya ang ibig sabihin nun? Ang pinapakita lang noon is that the horizontal at saka yung vertical motion ng isang projectile, they are independent of each other. So, ang isang projectile or ang isang bagay, kapag na-launch na siya into the air to become a projectile, it doesn't matter kung na-launch siya horizontally or kung na-drop siya. It doesn't matter kung na-launch siya with horizontal velocity or wala, as in the case of this blue ball, since it went from rest to moving. It doesn't matter. What matters is that its horizontal motion and vertical motion are separate. They are not going to affect each other. Yung vertical motion ng isang ball, hindi siya affected by its horizontal motion. And they are, again, independent of each other. Okay, anong evidence natin doon? Even though tinry pang mag-travel, merong horizontal coefficient ang velocity ng red ball, it still reached the ground at the same time as the blue ball, which does not have a horizontal coefficient for the initial velocity. Okay? Okay. And even though meron siyang itong si vertical distance, itong si red ball, meron siyang initial velocity since na-launch nga siya, at itong si blue ball, wala siya, they still are going to have the same, they still are going to reach the ground at the same time. Because again, those two motions, the horizontal and the vertical component of their motions, are independent. Okay, so this is the first case of projectile motion. Ito siya. Itong pagkaka-launch ni Red Ball from the table, that is the first case of projectile motion. This one right here, itong si Blue Ball, hindi yan projectile ha, bali it's a free-falling body. So you can consider this as a projectile. This one though, since it was launched and it covered a trajectory, this one is projectile, and it's the first case for projectile motion. Ayan. So let us try it out. Let's try out the following problem. So ang gagawin lang natin dito is I'll be showing you how to solve for missing factors, and then you will be asked to answer a similar problem. Don't worry, I'll be showing you naman the correct answers para mat-check mo lang yung mismong product mo. Okay, kasi checking the process, it will be done in our synchronous video lessons. It won't be done here in our asynchronous video lesson, so that I would be able to address some more questions that you may have. Okay, so for this example, a baseball is thrown horizontally off the table that is 1.5 meters high with initial velocity of 20 meters per second. How long will it take for the baseball to reach the ground? How far off will it be from the table? Okay, so tinatanong niya is yung time at saka kung gaano daw kalayo yung landing spot ng baseball ball from the table. So tinatanong niya yung time at saka itong distance na to. Okay, so gaano kalayo yung bola, yung landing spot ng bola mula dun sa point ng table, okay, kung saan siya nakatapat kanina. Okay, so to answer this problem, remember that the distance and velocity of the projectile has x and y components, dx and dy, that is in the previous sessions. Okay, and the vx and vy. So ang distance, meron siyang distance in x, distance with regard to y, and then meron din siyang velocity with regards to x and y. So remember that it is important to note too that the initial velocity has x and y components. So itong velocity na to, iba pa to sa initial velocity. Okay, so velocity only refers to the amount of displacement covered by the projectile per unit time. Whereas this is referring to the velocity of the projectile in the beginning. Okay, so yung mga givens natin are the following. Yung dy or in distance, vertical distance is 1.5 meters. And since it is downward, yung pagta-travel ng baseball is downward, we are going to put negative, okay, in the beginning. Yeah, that's the first before the first number in this integer, the first digit of this integer. Again, dy is equal to negative 1.5 because the distance from the origin is downward. Okay, pababa siya. Tulad siya ng first So a baseball is thrown horizontally off a table. So pababa siya. Kung yung origin, okay, let's go back. If the origin is this, it's 0, 0. Since pababa siya, yung distance na tinravel niya, vertical distance na tinravel niya is pababa. And that is with respect to the negative y-axis. Okay? So, reading the explanation here, since this is the distance between the launching point of the ball and its final position, and since it is along the downward y-axis, yung sign niya dapat negative. Now, for the initial velocity, horizontal initial velocity, which is 20 meters per second, it's similar to this one because the baseball is thrown off a table horizontally. So it's 20 meters per second. Since the direction of the force applied to the baseball that pushed it off the table is along the horizontal. That means, since horizontal lang yung force na in-apply, tapos it gave the ball a horizontal initial velocity, the vertical initial velocity is 0. Again, because the baseball was launched horizontally. Kumbaga, yung 20 meters per second is yung bilis ng baseball ball with respect to the horizontal. And hindi siya nagta-travel with respect to the y-axis nung mga time na yon dun sa initial parts ng scene. Okay, so yun yung mga givens natin. Yung mga hinahanap naman natin are the following. Okay, so we're looking for the time, yung time na in-spend ng baseball ball na nakasuspend siya sa air. And then, yung horizontal distance, yung distance na tinravel nung ball mula dun sa kung saan siya last nakadampi sa table, the tip of the table, and dun sa ground kung saan siya nagland. Let us keep in mind, we're not referring to the last, to the final position ng ball kasi there's a tendency for the ball to bounce, and that is already irrelevant to the problem. Okay. So how will we solve it? Let's begin by solving for t using the following formula. This is the given formula, okay, for looking for the vertical distance. And since vertical distance is already given, the VIY is also given, acceleration due to gravity is also given, only time is unknown. Okay, we can use this formula. Again, given yung dy, which is 1.5, and then tong si VIY naman is 0. And then si acceleration due to gravity is 9.8 meters per second squared. So t lang ang nawawala, we can use this formula. Since yung VIY is 0, you can just omit it. Okay? Since wala rin naman talaga siyang magiging effect, omit mo na lang siya and then just put gt squared over 2. Okay, so also for the next parts of this problem, you can do cross multiplication para ma-derive natin yung formula for t. Okay, so in this case, multiply natin ang d with 2, dy with 2, and then gt squared just stayed on one side of the equation. And then since ayan na siya, we can do now division in both sides of the equation. You notice we are not using the word transpose kasi gusto nating makita dito kung bakit sila naililipat sa kabilang side. Okay, so for you to be able to I quote, transpose it, you actually have to apply the rules of the equation property. No, this property of equation. Now, whatever you do on one side, you have to do it too on the other side, such as when you divide g from one side, you have to divide it from the other side. And since you have like terms, the numerator and denominator, you can just cancel that out. And then, since wala dito, you can just let it be. So, you will be left with t squared is equal to 2 dy and g. And t squared, as we know it, you can further simplify it by getting the square root of both sides of the equation. Again, applying the laws of equalities. Hindi ko alam kung tama yung name nun in mathematics, but that is what we do, okay? We don't just transpose, we always have to have explanations. So in this case, when you get the square root of t squared, you get t. And then since ito, wala pa naman siyang factors, hindi pa naman na-substitute yung mga givens, iiwan lang natin dyan si radical sign. Okay, so we have the formula. This is what we'll be using as the formula. We now substitute the givens. So the distance along the y-axis na dinravel ni baseball ball is 1.5 meters downward, so it's negative. And then under that is 9.8 meters per second squared, pero we're omitting the units here. Since we're looking for time, and since this is 9.8 meters per second squared, the sure thing here is that we will be ending up with seconds. Second squared siya, tapos magiging second siya. Okay, so you have to multiply negative 1.5 by 2, and then divide that by 9.8, and then get the square root of that, and you'll be left with 0.55 seconds. Okay, so that is the answer for time. We were able to look for time. So the baseball ball is it stayed suspended above the it stayed suspended for about 0.55 seconds. But we're not yet through. We still need to look for how far off will it be from the table. So in 0.55 seconds, how far off will it be for table? The formula we'll be using will be the following. So distance x, which is the missing factor, We're going to it's going to be equal to the product of Vix, initial velocity along the horizontal, multiplied by time, which is kakakuha lang natin, 0.55 seconds. Okay, so the initial velocity along the horizontal is equal to 20 meters per second. Remember that the baseball ball was thrown horizontally off a table. And then the time is equal to 0.55 seconds. Now, if you are going to equate these, you will be getting meters per second multiplied by second, and that is going to result to meter second over second, and you will just have to cancel out second, yung unit na yun. And you will be left with meters, which is the correct unit for distance. The correct answer for this part is 11 meters. Ayan. Okay, so the next part of this activity is going to require you to solve a problem by yourself. Okay, so prepare your paper and pencil na kanina pa nandyan. Get it? And then you can get your calculator too. Okay, and go ahead and go ahead, get them. Once you're ready, let's continue. Okay, let's continue. Alright, so solve for the following problem. Vilma pushed the jackstone ball horizontally off a table with an initial velocity of 30 meters per second. The table is unbelievably tall, being 3 meters high, so yeah, it's quite high. How long is the ball suspended in air? How far is the jackstone ball from the table? So you have almost the same kind of given. You have the same kinds of givens, and you're also looking for the same missing factors. So I hope that you will use the example which we did kanina in answering this question. So yeah, you're given now the time to shine. I said, go ahead and solve for the missing factors in this problem. Once you're ready, you can just play it once more for you to get the correct answers. To know the correct answers. Are you ready? Okay. So the correct answers for this problem are the following. So time, the jackstone ball is suspended for 0.78 seconds, and for the distance, the jackstone landed 23.4 meters away from the table. Take note that the distance we're talking about here is dx. Okay, it's the distance with respect to the horizontal, because the distance with respect to the vertical is already 3 meters. Okay? Okay, I hope that you got the correct answers. We will be having a talk about this in our synchronous video lesson. If you have some questions, you can ask them during those sessions, so that I'll be able to address them. Okay, so we're done with the first part, which is gather information, activity 61, catch me. Let us now proceed with the second part, which is gather information, activity 62, throw me. I see the objectives of this activity are the same as the previous one, so let me read them. Explain an object's motions in terms of its horizontal and vertical components, and then describe the motion of an object of a projectile that is launched horizontally. So you have to keep these materials ready: your sheets of paper or your science notebook, pencil, and a calculator. Let's continue. So what I would like you to do first is to analyze the following illustration. Okay, so in what way is this illustration different from the previous one? The previous one seems to be only fitting here. Ito, sa point na to, parang dito lang sila nahulog, the previous example. But now what we have here is from the same height. So it will rise from parang 0, then back to 0. Right? Okay. In the cannonball in this case is launched in such a way that it completes a parabola, an entire parabola at that. The ball is landed at the same height. The ball landed, I think my grammar there is quite incorrect. The ball landed at the same height with which it was launched. So if it was launched, okay, at this kind of height, ganito kataas, ganun din yung kanyang landing. Doon din siya nag-land. Okay? So unlike kanina. The same thing is observable when someone throws darts towards a dartboard. So yeah, if you look at the man throwing a dart towards a board, if the man's aim is along the horizontal, okay, along the horizontal line, he will surely be missing it. Kasi as you can see, if the man's aim will be like somewhere here or somewhere right here, he has the ability, he is enabling gravity to pull it downwards in such a way that it will still be hitting the dartboard. So if you're aiming it by launching it, the dart with a particular angle, it will increase the chances of a bullseye instead of just aiming, through the horizontal line. Yeah. I think this is the same concept din sa basketball, no? When they're shooting a ball, they're actually throwing the ball a bit higher than the ring, right? Or they're actually throwing it in a parabola, not through a straight line. Ayun. Okay, so once the dart is released, it will become a projectile with a particular velocity. The projectile has a horizontal and a vertical component. So meron din siyang VIX, meron din siyang VIY. And to get those values, kailangan mong gamitin ang mga formula na to. Okay, so for VIY, kung gusto mo makuha ang initial velocity with respect to the vertical, you need to use VI sine theta. And then if you need to get the initial velocity with respect to the horizontal, you need to use VI cosine theta. Alright, so let's put those concepts in practice. Let's read the following problem. Okay, so Michael is playing golf. He hit the ball with an angle of 60 degrees with respect to the horizontal with an initial velocity of 50 meters per second. So the first thing you need to do is to compute for the time the golf ball is suspended in the air. And then for the second one, you need to compute for the horizontal distance and the ball traveled. And then for the last task, you need to compute for the maximum height or dy reached by the ball. So yeah, you have the following givens. First, the angle that we are working with is 60 degrees with respect to the horizontal. That means to say the x-axis. And then the initial velocity was also given 50 meters per second. Okay, so given na rin ang Vy because remember, it was launched with respect to the horizontal. So the velocity with respect to y is going to be equal to 0. And then for gravity, that is actually acceleration due to gravity, which is also given 9.8 meters per second squared. It is negative because the motion is downward. Okay. So, let us begin knowing kung ano pa yung mga missing factors. We're looking for the time. We're also looking for the horizontal distance. We're looking for the vertical distance. And we're also looking for the horizontal component of the initial velocity and the vertical component of the initial velocity. Okay, so medyo marami yung hinahanap natin, no? Bale, limang factors. Let's begin with the first one. Let's solve for the vertical component of the initial velocity. So you'll be using the following formula given to you a while ago. VIY is equal to initial velocity multiplied by sine theta, which is going to be equal to the following. Sine 60 will be 0.866. Multiply that by 50, we will be getting 43.3 meters per second, and that is the first answer. So we only need to work for 4 more answers. Bakit ito yung inuna natin? You will know later. Inuna natin ang VIY because kailangan siya sa ating second solution. So Vy, which was equal to 0, given siya kanina, what we need to do to get time is we need to use this formula for Vy. Okay, so this one's equal to 0. VIY, kakakuha lang natin. It's 43.3 meters per second. And we all know 9.8 meters per second squared. That is acceleration due to gravity. And ang hinahanap na lang natin is time. Alright, so what we need to do is we have to carry out the operations first. We can just get these transposed to the other side by applying the laws of equality. Na yun nga, we will be adding it to both sides of the equation. This is not actually division, this is addition. Okay, so once nakuha na natin yan, okay, so we can see that it got transferred to the other side with a new sign because we're just adding it in both sides. Okay, so we have here 9.8 meters per second squared. T is equal to 43.3 meters per second. So what we need to do, since kasama pa rin si T dito, we are going to divide them. Okay, so this is the part where we divide them. If you divide this side by 9.8 meters per second squared, may iwan na lang si T. And then sa other side naman, you can just carry on dividing 43.3 meters per second by 9.8 meters per second squared, and you will be getting 4.42 seconds, which has a correct unit for time. Ayan. I hope nakaka-follow ka. Kasi syempre parang ganyan lang talaga yung processes na kailangan. Bali, kinuha natin yung VIY una kasi kailangan natin siya sa pangalawa. And you will soon know that they are connected pa. Okay, so, halimbawa, for the next one, this is not actually solving for T anymore. What we're looking for here is we're looking for the total time. Okay, so the amount of time it took for the ball to go up, it must be equal to the amount of time that it took for the ball to go down. And the total amount of time naman must be equal to the total amount of time it took for the ball to go up and for the ball to go down. So if it's 4.42 for the going up of the golf ball, and it's also 4.42 for the going down of the golf ball, what we have here is 8.84 seconds, which is almost 9 seconds. Total amount of time that the golf ball is suspended in the air. Ayun. So it's almost 9 seconds. Okay. Alright, now let's move on to the next part of our solution, which is solving for the initial velocity, the horizontal coefficient or component of the initial velocity. What we need to use as a formula for this part of the solution is the following. So remember, sinabi natin to kanina, it has to be, yung ating initial velocity must be multiplied by the result of cosine 60 degrees, which is 0.5, and it will be resulting to 25 meters per second. Okay, so kung yung ating initial velocity is 50 meters per second, with respect to the horizontal, ang tinatravel lang talaga ng body is only 25 meters per second. Ganun na siya kabilis with respect to the horizontal. Okay, so we got VIX. Now, what is the next thing we'll be doing? We will be solving for dx. And for us to do that, kailangan na natin gawin is to do the following. Just equate dx with velocity with respect to the horizontal and the total amount of time, which we were able to get a while ago. So the time we'll be using here is the total amount of time. So it's 9 seconds. And then for the, again, the velocity with respect to the horizontal, we will be using 25 meters per second. Yung kakakuha lang natin kanina lang. I multiply them, you'll be getting 221 meters. Ganyan kalayo yung tinravel ng bola with respect to the horizontal. Okay? Okay. So, the last thing we will be solving for is the maximum height reached by the ball, or dy. Now, how do we solve for that? We have to use the following formula. dy is equal to vy squared minus viy squared divided by 2g. Again, this is the formula for getting the dy. We all know that vy, there is no, wala siyang value, so it's only 0. And then the vertical component of the initial velocity is equal naman to 43.3 meters per second squared. Meters per second. So what do we do now? First is we just square it up and then divide it by negative 19.6. Okay, and then we will be getting 95.66 meters. Okay. Okay. Remember that you have to make sure that your units are they correctly match your missing factors. Okay. So, I hope that you were able to take note of the processes. In case hindi yun na maalala, you can always go back to that. Okay, so for the problem, for the similar problem you need to solve by yourself, you need to solve for the following. JP borrowed the golf club and the golf club, okay, nung kaninang player natin, which is Michael, tama ba? Which is Michael. Okay, and he hit another golf ball with an initial velocity of only 40 meters per second. It was with a lower angle of 45 degrees with respect to the horizontal. Now you have to compute for the total time. The golf ball is suspended in the air, and the total horizontal distance, which is dx, the golf ball traveled, and then the maximum height the golf ball reached. Okay, so I'll be giving you a moment to solve for this problem. I hope that you remember that I will be telling you kung ano yung tamang sagot. But with regards to the processes, we are going to discuss that during our synchronous video lessons. For the meantime, solve for this. Are you through? Okay. So the answers to the problem are the following. For the time, the golf ball is suspended in the air for about 2.89 seconds only. And then for the horizontal component of distance, the horizontal distance traveled by the golf ball is about 81.73 meters. Okay, and then the vertical distance naman traveled by the golf ball is around 40.804 meters or 40.81 meters. Did you get these answers correctly? Okay, I hope that for these two activities, you took note of your scores and that you will be reporting them on the upper right-hand corner of your sheets of paper or of your science notebook. Okay. Okay. The last part of our session will be gather information, understanding check. So what you need to do is that you have to supply the boxes, the empty boxes here, with the terms that will best complete their thought. So I will be giving you enough time to do this, and I hope that you will maximize the time that you have left. Okay, so I understand medyo marami tayong sinolve kanina. Yes. So you have to do this, and I hope that you'll be able to perfect this. Okay, because if you won't be able to do it, I am suggesting you go back to the previous sessions. Okay? So you can now begin. Are you through? Okay. The answers to this portion of our session are the following. Alright, so projectile motion involves two independent motions, such as horizontal and vertical motion, and vertical motion is influenced by the force of gravity. Okay, and then projectile motion is also of two types. There are projectiles thrown at an angle with respect to the horizontal, which an example of which is a satellite. Pwede yung pag-launch ng mga satellite natin, or any other examples that you can come up with. Okay, and then the other one is projectiles that are thrown horizontally, such as those that are thrown off the table. Okay. So yeah, that's it for the last part of this session. Okay, so for this session, you were able to finish the following. So first part of the session is gather information, activity 61, catch me. And then the second part of the session is gather information, activity 62, throw me. And then the last part of the session is gather information, understanding check, concept map. We are still working on the following learning competency, describe the horizontal and vertical motions of a projectile, and I hope that you were able to follow through with your copy of the 7E-based self-learning module for Science 9, which I developed. So that's it. This is still Sir CJ, and I hope that I will be seeing you in the next session for Physics 9. Have a good day.